So this is the original standalone mains controller. That's the socket, the outlet socket, and the plug. Right. If you wanted to make this into a remote operated controller with a foot switch like this, this is a floor foot switch. For this I've got it set up on the bench here. Then all you need to do is interrupt the supply that comes from the plug to the socket, and take it out to your foot switch. In there, all there is a micro switch, which you probably need to go into anyway to replace the cable, because this one had literally 6 inches of cable where my thumb is. So it had to be dismantled and put a longer cable in. To do that, you squeeze it together, slacken the screw, push out that pivot pin, and then the two halves come apart. Inside, you've got a micro switch just like this. It's a momentary, so that's different to this toggle. Press on, press off. This, the foot switch, you press down and the thing stays on for as long as it's pressed, and when you let go. But you can get, this is identical type of micro switch, and the difference here is a toggle mechanism. Don't know if that's apparent. And there are different types of toggle switches, so you don't have to use a micro switch. You don't have to buy one. You can make one out of a couple of bits of ply which are hinged together, and put anything that can make and break your circuit. This is for a door, which has a plastic roller there. It's adjustable for length, so you could mount that on a bit of wood, have a hinged pedal that you press to operate, and it's spring loaded, so you let go and it'll come back. So it's easy enough to make. On this one, which has got the foot switch connector fitted, I've done it so that I can remove it. I don't always want to have a foot switch and a big long cable on there. Let me plug the lamp in. So I want that to operate without having the foot switch on. Therefore, I put a bypass switch in. At the moment, it's bypassing this. If I switch it to come through there, so that's what this is. There's the foot switch that comes out via this connector. But if it's not in situ, you can put the bypass switch on, and the current will bypass the foot switch and come and let the thing be operated by itself. So far, I've shown how to create a multi-standard mains outlet, and the same with a flying lead, but both with the universal IEC kettle connectors there. This one has the remote switch connector. I could have built it in the same as was done there, but it was more for able to show what was happening. Both of these though, I've incorporated a dimmer module, a mains controller module. If you only want to switch the mains and have multi-standard, you don't need a dimmer module. For me, for the items that I want to use, it's very, very handy. As a dimmer, as a lamp dimmer, I don't really have any need of a lamp dimmer. If I want light on it, I probably want it on full. But for motor controls, it's very good. To adjust the speed of things. Don't always want your motorized equipment to be running flat out. So that's what this little episode is about, how to create your mains controlled version. If you use a bigger box such as this, obviously you're not pressed for space, and you might not want the external pedal, so you don't need this stuff on the side. So all you have is your outlet and the mains controller to be mounted. In this case, this is supposed to be a waterproof box, but I don't want it getting wet. That wasn't the point. It was a nice, strong, large enough little box that I drilled a hole in the cover that I was able to mount the controller module direct onto there. You don't have an earth on these. You've got mains in, mains out. If I flip it over, you can see that one side of the mains going in is connected directly to the mains going out. So you need to be careful that, you know, your life is in your hands. I've deliberately left loose strands. If you're going to wire up multi-core mains cable, I strongly suggest that you get a soldering iron or a soldering gun and twist the bared ends together and stroke them with a soldering iron or gun and put a bit of solder on, so that you end up with, instead of multiple loose strands, you get one solid lump, which is much better for gripping with and for not fracturing eventually and pulling out. That's one thing to be aware of. Another thing is I deliberately made this cable overlong so that it pokes out further than it needs to from the screw. Well, if you do that here, you touch this heatsink. Now the heatsink isn't actually live. I've tested this, nor this metal mounting plate. But if you poke a cable through that's a bit too long and it touches that, then it is live. Then you've got all sorts of problems. So this isn't made with safety in mind. It's doing a job. You need to treat things with a bit of respect so as not to fall into any potential hazard traps that might be around. If you use it how it should be used, carefully, with your safety in mind, then it should be okay. I'm 70 years old in another week. I'm still around. I've got everything I was born with, but I am careful. I don't take silly chances and unnecessary risks. While you're on the module, this trim pot adjusts the minimum rating that the controller gives. So obviously fully clockwise, that's maximum output. So whatever your input is should be what you get on the output. This reduces that down to the minimum that is set on that. So if you were driving a lamp, that would adjust how dim you could turn the lamp down. If it was a motor, that would adjust how slow your minimum motor speed would be. I haven't changed these. I don't need to, and I don't like putting anything metal in and around where there is metal. It's too easy to have an accident. I mean, I have an insulated trim pot, so I could do this if I wanted. I'm just pointing out that that adjusts the minimum speed in case you need to do that. So there's a lot more space around this one for heat to dissipate away. This one, not so much. That's how it would fit in. So I wouldn't want to put high current, high power devices coming off of this. It's just common sense. This module is rated, according to the Chinese spec sheets, at 2000 watt, 2 kilowatt. It has a removable potentiometer, which is easier for mounting. This one, although it has a metal plate to allow the potentiometer to be mounted solidly with the item, the heatsink looks too similar for me to have any confidence that this can live up to its rated spec of 4000 watts, 4 kilowatts. I mean, what it has to do is chop off parts of the mains, and it does that by dissipating it as heat. So you get heat coming off. You get higher spec controllers that actually have little fans on, which is fine if you have enough space for that heat to move away. Well, it's not going to move very far if it's trapped inside a box. So this is rated at 2 kilowatt, this at 4 kilowatt. I would take such specifications with a pinch of salt, to be honest. I would never want to run them up to their top ratings. 2 kilowatt, I wouldn't take past about 1.5 kilowatt. Always allow some margin of safety. It's my protection. I don't need to test whether the manufacturer or the wholesaler is lying or not. I just want to have to look after myself. Similarly, as I've pointed out already, one of the inputs, this is the input pair, this is the output pair. One of the inputs connects directly through to the output. So if the live and neutral are reversed, you would assume that this is the live input and this is the controlled live output, but there's nothing that states that. But if they're reversed, then this is live. So your live input is also live all the time on your neutral wire if you've got them the wrong way around. You have your input pair and your output pair, so there's no facility for earth. Well, on this arrangement, you don't even have an earth on your output connector, but you certainly have an earth on the input. It's not used. There's nowhere for it to go. it can't go onto the module itself. There's no facility for earth. But there certainly is on this. You have an earth pin. Yes, this is the earth. So if you ignore that, you are creating a potential hazard that you needn't do. All you have to do is connect your input earth, ignore the module, and take it to your output earth. And then whatever you plug into here will be protected with an earth, irrespective of the control module. Again, this is common sense, and it's for you to decide to do. It's no one going to tell you to do that. Right, moving on.